Hello again. In this video we're going to look at converting numbers to strings. In the last video we learned how to use from-chars to convert strings to numbers, and now we're going to go in the opposite direction. This toChars function has similar advantages to from-chars. It's safe, it's efficient, it does not do any locale processing, it does not allocate memory or throw exceptions, and so on. If we use these two functions together, we can get a so-called round-trip guarantee. If we have a number and we convert that to a string with toChars, and then we pass the result as an argument to from-chars, then we're guaranteed to get the original number back with the same binary data even. Obviously, that assumes that we're using the same implementation. If you send the string over a network and you convert back on a different computer using a program that was compiled with different options, then there are no guarantees. The interface looks the same as from-chars. We have these two pointers to constchar, which define a range of characters, and we have a third numeric argument. This time the pointers define a range in the destination, so this is where we want the result to appear, and this will be the number that we want to convert. We have to provide the buffer ourselves, and we have to make sure that it's large enough to hold the result. So the simplest way is to have an array of characters, not const of course, because we're going to write into it. I'm using 100 here, which should be safe enough, but if you want to be more precise, then there are functions in the limits header which will give you the exact number of digits for each numeric type. Then we call it the same way. We give it the pointer range and the number. This buff is the name of the array, so that's a pointer to the first element, and then adding size will give a pointer to the last +1 element. The return value is the same. It has a different name, but it's basically the same. We have this pointer to the last +1 element in the result, and we have an error condition. This time there's only one possible error condition, which is if the buffer is too small for the result, and the error condition is value too large. One thing that's very important to remember is that the result does not have a null terminator at the end. So if you try to use this as a C-style string, then horrible things are going to happen to your program. If you want to do that, then you must add the null terminator yourself, and that's very easy. We have a pointer to the last +1 element, so we can just dereference that and assign it to null, and then the data will be followed by a null terminator. Another possibility is to store this result in a string object, so that will involve copying the data, and it may involve a memory allocation, which could throw and will take time. So depending on your application, that may or may not be acceptable. If you do want to do that, then string has a constructor which takes a pointer to character and the number of characters that the pointer is pointing to. So we can give that the start of the buffer, and this calculation will give the number of elements, and then we can use that. There is actually another possibility in C++17, a string view, and we're going to look at that in the next few videos. So let's try this out. We have our array of characters. We have the number we're going to convert. We call toChars. We pass the pointer range in this buffer where the results will go, and the number that we want to convert. We store the returned struct. Then we add the null terminator to the result, and then we can just print out that array of characters. And we're also going to try and construct a string using that data. Okay, so that worked, so we get 42 in both cases. If I don't put a null terminator, I'm sure you can all guess what's going to happen, but let's see it anyway. So we've got gibberish in our result. So the left shift operator, it processed the first two characters of the result array, and it got 4 and 2, and then it keeps looking for a null terminator. So it goes on, and it won't give up until it finds one, and eventually it gets there. But we could have had much worse. We could have had a crash or some bizarre behavior. So don't do that. Always add a null terminator if you need one. With from cars, we had an optional argument with floating point conversions, which allowed us to tell the function what formatting was being used. And we can also do that with to cars. This time it'll tell the function how we want the output to be formatted. And we have the same four possibilities we had as with from cars. We have scientific, fixed, hex, and general. These are actually going to use the conversion specifiers from printf. So we have an array with buffer overruns and printf. This is in danger of turning into a C video, but don't worry, we're going to stay with C++ 17. So scientific uses %e, fixed uses %f, hex uses %a, and again this conversion ignores the 0x, and the default uses either scientific or fixed. We can also pass another argument which will give the precision, which is the number of digits we want in the result. I have written a function which takes the number we want to convert as an argument. We create our array again. We call to cars. We check the error condition. So if the value is too large, the buffer is too small, then we need to handle that. And otherwise we can do something with the returned data. First of all, I'm going to call this function with a nice, straightforward, ordinary floating point number. And then I'm going to call it with this monster. So what is going to happen? One thing that's worth knowing is that the number of digits in a double is generally somewhere between 15 and 19. It's not actually specified anywhere. So here are our results. So the first one is processed accurately. The second one has been truncated. So let's see what happens if the buffer is too small. So 10 is not going to be enough to hold that number even after truncation. It's okay for the first one because that's only 6 digits and we have a buffer with 10 elements, but that's not enough for the second one. So we get the value too large error condition. Just put that back. I could also put a format specifier here. So let's try scientific because the others aren't terribly interesting. And there we get the scientific format. So we have this exponent which is actually 0, because to get the correct result you just have to multiply this by 1, and 10 to the power of 0 is 1. I could also add a precision, so let's try 3, let's see what that does. So now we have 3 digits after the decimal point. Okay, so that's it for this video. I'll see you next time, but until then, keep coding.